In this video, I'll show you how to easily create forms in Flutter without the typical boilerplate that comes with it. To do that, we'll take a look at a powerful package that lets you create full-featured forms, from a small login form to complex forms where you can validate input data, display appropriate error messages in the right language, and create dynamic input procedures. This package is called Flutter Form Builder. There have been many changes since my last tutorial, and the package is now available in version 4.2. In this tutorial you will learn step by step all the useful features of the package so you can use it profitably for your future projects. If you want to watch only certain parts of the video, you can use the timestamps to skip ahead to the corresponding part. However, if you have never heard of this package, I recommend watching the tutorial from the beginning to the end. And if you have watched the video, I would really appreciate a quick feedback from you. I put a lot of effort into this tutorial and hope that it will help you to better understand this package. So let's get started. Thank you very much for your attention and enjoy watching. Before we start setting up the package, I would like to take this opportunity to briefly draw attention to the developers working on this package. Mr. Danvick Miller and numerous other developers are continuously working to extend the feature set, correct existing bugs, and generally improve the package. If you want to support this package, you can contribute by giving the pubdev documentation site a like, the GitHub repo a star, and if you want to go one step further, go to Mr. Miller's Buy Me a Coffee site and buy Mr. Miller a tasteful coffee. To set up the package, first go to the documentation page, click on the Installing tab, copy the dependency line and paste it into your pubspec YAML file under the Dependencies section and save the changes. To check if the package has been successfully downloaded and installed, see if the FormBuilder widget name appears in the autocomplete dialog. By adding the widget to the widget tree, a new import statement should appear at the very top. Alternatively, you can manually insert the import statement by copy and pasting in the file you want to use the package. The core of the Flutter Form Builder package is the Form Builder widget. This widget is the glue that holds everything together, so to speak. Therefore, in order to create fully functional forms, we should familiarize ourselves with its properties. The first and one of the most important properties is the key property. Unfortunately, we cannot view or manipulate the form's data through the widget itself. In order to still be able to use all the important functions of the form, such as reading, modifying entries, validation, and so on, we sneak another object into the Form Builder widget. And this object is a so-called global key. So we create a global key object, pass it to the Form Builder widget using the key attribute, and then use this object to view and manipulate the state of the form. There are two important details to keep in mind. First, we create the global key of type FormBuilderState, and second, we create it outside the build method so that it is not regenerated with every build cycle. And now with this form key we can view, modify and process the form data. How this works exactly I'll go into in the course of the video. The next property is the child property. This should be familiar to most of you. The child property is the container for our form fields and the only required parameter, which is why we still get an error displayed here. For demonstration purposes, I create a very simple form by adding a column containing a text field and a button. Then we have the onChanged property, and as the name implies, this is triggered whenever a form field has changed. As an example, I provide a simple print function which prints a text to the console, but you can use any callback function of your choice. Now, whenever we make changes on any form field of the form, the onChanged callback function that we've provided is called. As you can see, even tapping into the text field is handled as a change, and of course on every single keystroke within the text field, the onChanged function is called as well. With Autovalidate mode, we can change how validation is handled. There are three modes that we can use by providing an Autovalidate mode object. With Autovalidate mode always, we can autovalidate the form and form fields even without user interaction. Select Disabled to disable the autovalidation and select On User Interaction to only validate after each user interaction. Later we will talk about validation in detail and we will have a look on how the form acts on every single mode. Next is onWillPop, which needs a function returning a future of type Boolean, and if that callback returns a future that resolves to false, the form's route will not be popped. In other words, you can prevent users from leaving or closing the form. To demonstrate this, I will use my pre-built example app where I implemented every single aspect of this tutorial beforehand to familiarize myself with the package and for you guys to have an example app that you can always refer to. If you want to use this app, the link to the GitHub repo is in the video description. So let's navigate to another screen with a form that has an onWillPop implementation. So here we can see an example of a form builder widget with a very simplified callback function just for demonstration purposes. This function returns false and therefore we are not able to pop this route. But if this function was returning true, then we would be able to go back to the previous screen. Then we have a property called initial value, and by providing a map of string dynamic, we can set initial values for each of our form fields. In this case, we just have one field, which is our text field, and the name of this text field is also text field. And this name is the identifier that we have to use to set an initial value for this particular field. And within the map, we add the name of the field as a key, and the content that we want to be displayed initially as a value for that key. And now our text field displays the initial value. And finally we have the property skipDisabled. To explain this, I have to mention one piece of information in advance, namely that form fields have a property called enabled, which takes a Boolean and setting it to false would disable the field. And with skipDisabled, we can determine whether the form should ignore disabled fields. Perhaps you are now wondering when exactly the fields are ignored, and that's why next we'll look at the basic functions of the form. With Flutter Form Builder, you can easily reset your form. We can reach all important functions through the global key which we created at the very beginning. Here we have a simple form, a text field and a reset button. To reset the form by clicking on the button, we use our form key inside of the onPressed function. The form key gives us access to the current state of the form, and this state object has a method called reset. If you want, you can also make the keyboard disappear by using this statement, but that's optional. The app is already running using this implementation, that's why I don't have to save the file. And now by clicking the button we can empty the form field. The global key also gives us access to the current value of a field. Therefore we once again use our form key variable to get the current state of the form, which is of type FormBuilderState. This object has a getter called fields, which returns us a map of string FormBuilder field state. And if we jump into the FormBuilder field state class, we can see that this extends FormFieldState. And the class FormFieldState has a getter called value, which returns us the current value of the form field. And because FormBuilder field state is extending FormFieldState, it also has this getter. So in order to get the value, we use the name of the field, which is the identifier, as the key, and then the getter method value. Also notice the value that is returned is of type dynamic. If you continue to work with this value, you might have to convert it first. Now let's save that value in a variable, and to display it I create a simple snack bar that pops up at the bottom of the screen. And as you can see, we can easily access the content of this text field. Okay, You might be wondering why I'm going into two functions right now, saving and reading the form. This has to do with how the form handles the data. Unlike the previous lesson where we read a single form field, now we want to read the entire form. This means the input of all form fields. As you might have guessed, the inputs of all form fields are combined into one map of string dynamic. As before, we need to access the current state again. This time, however, we don't want a single field but all fields at once. This is easy because the FormBuilder state class, which we can access with .currentState, also has a getter named value that returns the entire input as a map of string dynamic. As we did with the form fields, we store the return in a variable and display the contents with a snack bar. But as we can see, our map is empty. And this is because we have to save the inputs first. And we can do that with the save method. When we call this method, then all the inputs are saved. It is also possible to save specific fields by accessing the respective field as before, because also the class FormFieldState has a save method. This way we can flexibly decide which field inputs to save and which not. Now that we know what the form is capable of, I'd like to return to an unresolved issue I raised at the very beginning when talking about FormBuilder properties. More precisely, it was about the property skipDisabled and what exactly can be understood by skipping disabled fields. Here we have two text fields. The first one is enabled and the second one is disabled. If we save and read the data, we can see both fields have been saved. Now let's see what happens if we set skipDisabled to true. The form behaves as if the second text field does not exist. Up to this point, we've covered how to reset the form, how to read the data of certain fields or all fields at once, and how to save the inputs. Now let's have a look at the last piece of the puzzle, how to validate the user input. Later in the tutorial we will cover the topic of validation independently. We'll look at built-in validators, how to create a custom one, how to perform multiple validations, how to create conditional validations, and how to create custom error messages. But first, let's get to the basics. Let's have a look at the example app. We have a simple text field that requires a certain user input, which is the word yes. If we leave the text field empty or enter something different, an error message appears below the text field, which says this field value must be equal to yes. In order to implement such a validation behavior, two things have to be done. First, we must define for the text field what it should validate, and second, we use our global key as before to perform the validation. One property or so-called core attribute all fields have in common is the attribute validator. To this we can pass one of the built-in validators. As I said, later we will look at all the built-in validators one by one, but to touch on the subject, here's an example. All of the built-in validators can be found through the class FormBuilder Validators. To check if an input equals a certain value, in our case the word yes, we can call the equal validator method. This needs the build context and the comparison value. Next, we need to perform the validation, which we usually do before the form is submitted, so within the onPressed function of our submit button. As always, we use the form key to get the current state, and then we call the method validate, which returns true if the validation passed or false if the validation failed. For example, we could arrange for inputs to be saved only if the validation was successful. This example can also be implemented in a shorter way by using the method save and validate. But keep in mind, by using save and validate, the form will be saved regardless of the validation result, as you can see in this example. Next, let's look at the core attributes. These are the attributes that all fields have in common. You already know some of them, and basically they are all self-explanatory, but for the sake of completeness, let's briefly go through them. The name attribute is the unique identifier of the field. Whenever you read a field or pre-populate it by setting its initial value, you have to provide the name of the field as the key to retrieve or manipulate its current value. You can pre-populate form fields with the initial value attribute. There are two ways to do this, either directly by the field or by the FormBuilder widget. Both of them have this attribute, but whereas with the field you can specify the value directly, with the FormBuilder widget you have to pass a map of string dynamic with a key value pair for each field. You can disable fields by setting the attribute enable to false, but keep in mind the input value of a form field is saved even if the form field is disabled. Only if the skipDisabled attribute of the FormBuilder widget is set to true, disabled form fields are ignored. With the decoration attribute you can style your fields, and this should be self-explanatory. With the validator attribute you can set conditions for the corresponding form field that must be met for validation to be executed successfully. For example, we could say that only the word yes is accepted as a valid input. You can use predefined validators as well as your own. You can combine multiple validators and even attach them to certain conditions. Just like the FormBuilder widget, the form fields also have an onChange attribute. In the chapter about the FormBuilder Basics, I have already explained how this works. And finally, the attribute valueTransformer. With valueTransformer you can change the value of an input field before it is saved. We can see a small example here. We transform the value to uppercase before saving it. One thing that makes the package immensely useful are the pre-made fields. If I counted correctly, there are currently 24. It would take too long to explain them all in detail, however, we will go through them one by one so that you get an overview of which fields we have, what they look like, what function they have, and how the return value looks like. Okay, let's get started. First one is the classic checkbox, which can either be true or false, or null if the property TrueState is set to true. Checkbox group creates a list of checkboxes for selecting multiple options and returns a list of the selected items. Chip's input displays selected entries from a drop-down list in a chip-shaped preview. In addition, the list is filtered according to the input. Choice chip is like radio buttons but visually more appealing. Again, we have a chip view from which we can make a selection. With color picker fields you can display a very user-friendly selection dialog from which you can choose a color of your choice. Also, datetime picker shows you a very user-friendly selection dialog to set date and time. With date range picker we have the same thing, but here we can select a time period. Then we have the classic drop-down menu that shows you a listing from which you can select an entry. Filter chip is like checkbox group, but also with the chip design you can select multiple items which will be marked with a check mark. Radio group should be familiar to everyone. Here you also have one option to select. With range slider you can define a range by setting a minimum and maximum value and then select a range that is between the boundaries. The ratings field works similar to Amazon's rating system, where you can choose between 1 and 5 stars. Searchable dropdown is like the classic dropdown, but here you can enter a search term and the selection list gets filtered. Segmented control is similar to radio group, where you can select one of the given options, but it has a different UI. Signature pad lets you write your signature and returns the coordinates of the drawing. Slider lets you choose a numeric value within a predefined range. Switch is similar to a single checkbox. You can turn it on or off, which returns either true or false. Then of course there's the text field that we've already seen a few times. Touchspin displays an increase and decrease icon to select a numeric value. You can define the min, max and step value. Type ahead is like the searchable dropdown. You can also enter a search term to filter the item list. With File Picker you can pick a file from your device, from Google Drive or the Gallery app. Same goes for Image Picker, but here of course you can only pick image files. With location fields, I guess you can select a location, but to make this work you need a Google Maps API key. And last but not least, the phone field. With this field you can choose the country code from a list of countries and enter a phone number. In addition, the national flag of the selected country is displayed. If this large selection of fields is not enough for you, there's also the possibility to create your own custom fields. Here we have an example of a custom form field which I found in the documentation. To build your own custom field, you can use the FormBuilder field widget. This one has two required parameters: name, to be able to identify it, and builder, which is a function that takes a form field state of dynamic and returns a widget. In this example, we return an input decorator, which is like the frame of our input field. It is responsible for displaying the label text. We can create a padding around our actual field widget. We can define a border and an arrow text, among a lot of other options. To define the frame, it requires an input decoration object, and the actual content, which is our custom field, is passed to the child attribute. For example, a container with a height of 200 and a child of Cupertino picker. With an item extent of 30, and the options that we want to display are taken by the children attribute as a list of widgets. We define this list at the top because we also need it for the onSelectedItemChanged attribute. This takes a function with an integer as input, which is the index that is currently selected. So whenever we select a new value, this function is triggered, and because of that we have access to the new index to save the change within our field's state. And to actually change the field state, we can call the didChange method and pass in the selected value, which we get from the options list using the index variable. This is how you could create a custom field. In September 2020, Mr. Miller also wrote a Medium article about how to turn any Flutter widget into a form input. However, I don't know how up to date this is and if it still works the same way today, but I think as an additional reference it can help. Link in the video description. If you need to change the values of any field programmatically, you can easily do that. To change the value of a specific field, use the global key to access the current state of the form, specify the field with the field's property, and then call the didChange method. That's what I already spoiled in the previous part. Alternatively, you can also change values calling the patch value on the current state object and pass a map to override the fields. To validate form inputs, Flutter Form Builder provides many built-in validators. All of them can be called using the class FormBuilder Validators followed by a function call for the specific validation type. The credit card validator requires the field's value to be a valid credit card number. The date string validator requires the field's value to be a valid date string. You can check for valid email addresses. You can check for equality or inequality. You can check if the input is a valid integer. You can check for IP addresses, so for numbers ranging from 0 to 255 separated by dots. With match you can provide a regular expression, and in this example we see the one for the email validation. You can set a max value. You can set the max length for the input. The minimum value. The minimum length of the value. You can make the field's value to be numeric only. You can forbid to leave the field empty. And you can check for URLs. Now I will show you how to create a custom validator. We are back to the Form Basics screen where I explained how to validate the form input. We have a text field with a pre-built validator which checks for equality, and only the word yes is accepted as valid input. Let's recreate this validator using our own validation function. If we have a look on the validator's property, we can see that the FormBuilder validator's object is not necessary. We just need a function that takes a string and returns a string, and that's pretty easy to create. So let's delete this validator and instead use an anonymous function with a variable called value. And within the body we check if value equals yes. If it doesn't, we return a string that says answer must be yes, and if the value is equal to yes, then we just return null. Let's save and test it. And as you can see, we implemented the same functionality but wrote our own custom function. You can also use multiple validators at once. Let's say we want someone to enter a number in the text box, and that number has to be in a range from 0 to 100. So we would have to check the entered value for 3 conditions. First, the input must be an integer. Second, the input should be greater than or equal to 0. And third, the input should be less than or equal to 100. If we wanted to continue using our own validator for this, we could add more if statements, but there's a much more convenient way. We can combine multiple validators by using the compose method from the FormBuilder Validators class, the same class that contains the validation methods. As you can see, the compose method needs a list of functions returning a string. So we provide a list with 3 validators, integer, min and max. Let's see if everything works. Perfect. In addition, we can also add our own validators here. Let's say we want to accept only numbers that are even. We can just add another custom validator for that. Here we have an example for conditional validation, which I got from the documentation. It asks to select a programming language. And only if we choose the entry other, we have to specify more details in the text field below. Otherwise we don't. So the text field may be empty unless we have selected other. So we need a custom validation function for the text field in which we check which value was selected. And as you probably know, we need our global key for this again. We get the selected value, check if it's equal to other, and if the text field is null or empty. There are cases where the existing error messages are not sufficient. That's why I'm going to show you how to create your own error messages. Let's assume that we have a form to register where we have to enter an email address, and if we enter an email address that already exists, that should also be displayed as error text. To do this, we define an empty variable for the error text at the top before the build method, and a method that just serves as a simple example. We have a list with the already existing email addresses, which is like our database, and it is queried whether the entered email address already exists. Using the input decoration of our form builder text field, we can also specify the error text. We use the error text variable, and as long as it is null, no text will be displayed. Which is why we need to implement the logic to change the value of the error text variable whenever an existing email address has been submitted. So within the onPressed method of our submit button, we get the current value and then check if the email exists using the email exists method that we defined at the top. And in any other case, we don't want the error text to be displayed, therefore we set the email error variable back to null. Now that we've seen how validation works, let's have a look at how the auto-validation modes work. Here we have a checkbox field where auto-validate mode is set to always. That's why it's already displaying the error message. The checkbox has to be checked. And here's our old good text field that wants only yes as valid input. And here the error message appears as soon as we tap into the field, which is our user interaction. If we set it to disabled, there is no auto-validation, but don't get me wrong, the field's validators are still working, but it's not automatically validating. Before I set the auto-validate modes on the fields, I tried it on the FormBuilder widget, but there the auto-validate mode always behaves the same way as the on user interaction mode. So if you want the auto-validation always to be active, better set it in the field instead the FormBuilder widget. Let's move on to the final lesson of this tutorial. How do we enable internationalization in Flutter Form Builder? It took a while for me to get it right, but basically it's very easy. Our device language is set to Spanish, yet our error text is displayed in English. We want to change that. First, we need to add a few entries to the pubspec YAML. We add Flutter locations and the intl package. Let's save, and now we just have to modify our material app. We add the supported locals and the localizations delegates. You can find this code in the documentation. Let's save and restart the app. And as you can see, our error message is displayed in Spanish. And if we change back to English, our app language changes as well. And that brings us to the end. I hope you enjoyed the tutorial and that it helps you to implement the package in your future projects. If you use the package and think the project is worth supporting, don't forget to like the documentation, give a star to the GitHub repository, and show some appreciation to the developers through the donation links. Also, I have donation accounts as well if you would like to support me in my mission. That would help me a lot. And if you liked the video and want to support me and my channel, feel free to do so by liking, sharing the video and subscribing to the channel. All important links and also further information can be found in the video description down below. If you have any questions, thoughts or recommendations, feel free to post them in the comments. In case of technical issues regarding the package, I advise you to report it directly to the developers by opening a case on the GitHub repo site. Thank you for your attention, I wish you a wonderful day and see you soon.